The first basic concept of probability is that all probabilities must fall on the number line between 0 and 1 inclusive. That means that all probabilities will be numbers between 0 and 1, but may also include 0 or include 1. If the probability of an event is equal to 0, then we say that that event is impossible. If the probability of an event is 1, then we say that that event is certain to occur or guaranteed to occur. So where a probability falls on this number line basically tells us how likely an event is to occur. The midpoint of this number line is 0.5, or in other words, 50%. There's a 50% chance, or a probability of 0.5, of tossing a coin and having the coin land on heads. The probability of being struck by lightning is very, very small, very close to 0, but it's not impossible. The probability of someone eating pizza in their lifetime is very, very high, very close to 1, but not certain or guaranteed. When calculating probabilities, try to think about the likelihood of that event and where the probability should fall on this number line. If an event has a probability of less than 0.05, that is any number between 0 and 0.05 inclusive, then that event is considered to be unlikely. Consider the event of rolling a fair die. All of the different outcomes are equally likely. That is, that you have an equal chance of rolling a 1, 2, 3, 4, 5, or a 6. As an example, let's find the probability of rolling a 3. Since there are a total of 6 different outcomes possible, the 6 will be the denominator. There's only one way to roll a number 3, and so the 1 is our numerator. The probability of rolling a 3 on a fair die is 1 divided by 6. This is approximately 0.167, and we could also change this into a percentage and say that we have about a 16.7% chance of rolling a 3 when we roll a fair die. Notice that the same probability would occur if we were to replace the 3 with any other number in our sample space. That is, if we were asked to find the probability of rolling a 1, we would still get 1 divided by 6. If we were asked to find the probability of rolling a 6, we would still get 1 divided by 6. Now let's find the probability of rolling an odd number. Again, there are 6 different outcomes, and there are 3 of those outcomes that are odd, the numbers 1, 3, and 5. That tells us that there are 3 ways for us to roll an odd number if we were to roll a fair die. We can call this the probability being 3 divided by 6. We can reduce that to 1 divided by 2. We can change that to a decimal, and we can also convert to a percentage and say that we would have a 50% chance of rolling an odd number. Let's take a look at an example using a spinner. If someone were to spin the following spinner, let's determine the probability that they would land on the number 2. Because of the fact that each section or each number on the spinner does not have an equal slice of the spinner, that tells us that these are not equally likely events. The probability of landing on the number 2 is not the same as 1 divided by 4. Although there are 4 different outcomes, the numbers 1, 2, 3, and 4, and there's only one way to land on the number 2, the number 2 takes up a larger piece of the entire area than the other 3 numbers. So the probability of landing on the number 2 is not equivalent to 1/4. If we think about dividing the spinner into equal slices, then we will find that we would have 8 slices of equal size on our spinner. The number 2 takes up 4 of those 8 equal slices. So the probability of landing on the number 2 would be 4 divided by 8. or we could call that 1/2. The probability of landing on the number 1 would be equal to 2 divided by 8, or 1/4, because the number 1 takes up 2 equal sections of the 8 equal slices. The probability of spinning and landing on the number 3 or the number 4 would each be 1/4.